G'day, I'm Glenn Morris from the Smart Energy Lab, and today I've got James Foster from Empower. Great to have you here, James.
Good to be here, Glenn.
You had a bit of drama getting here.
Oh, yeah. It's, I think, the rainiest day in Sydney ever, so the flights were all delayed and then a heap of issues. But we got here.
And you couldn't hire a car?
No, so I had to get an Uber to a car next door and then car next door here. So, yeah, anyway, got here in the end.
So it's going to be a long day for you.
Yeah.
And you'll be getting back into floods.
Yep. So, might not make it home, but we shall see.
Well, we do have guest accommodation here if you want to sort of stick it out.
That could work.
To stay for the Grand Prix, to say to the missus, sorry I couldn't make it back.
Yeah, unfortunately I've taken the car, so the wife's had to take the baby to daycare without the car, and it's all a bit of a mess. But I might take you up on that.
I'm serious. It's just through that wall, actually.
Okay.
Yep. So anyway, Empower. For those who don't know anything about Empower, tell us a little, your elevator pitch. What is Empower?
Yeah, sure. So the company was sort of started 10 years ago or so by the managing director, who really wanted to be in the VPP space. So really looking at trying to minimise bills for consumer and supporting the grid. So he sort of wanted to really design the software to be able to do that, but there was no hardware platform that he could find that was flexible enough to implement all of the amazing stuff that he kind of wanted to do. So then I came on board 6 years ago, and we started to design a hardware platform from scratch to be really flexible and be able to support all of the VPP software that we need to run in the future. Right,
so you actually came at it from the software side first, which is about maximising the benefit to the customer. The hardware came second. It's often the other way around.
Yeah, exactly. Yeah, so I think, in my view, it's better to try and lead from the services side and reducing the bill for the consumer, improving the whole grid as a whole. And I think that's sort of where we're really trying to attack this from. The hardware is basically a platform to be able to run the software as efficiently and as flexibly as we can.
So what's your role at Empower?
So I'm the CTO. So I'm, as I said, I've been there for 6 years now, and we've been through a few product iterations, and we're now on the ElectroBank 14. So I'm primarily a power electronics engineer. So I've designed the inverter and the battery system. So
do you sit in a glass office and look down on all these?
Oh yeah, there's so much, so many people, and it's very much been a sort of startup culture. So there's been when I started, there was sort of just 2 to 3 engineers. We developed the product from the ground up with just a few of us, and now we've just received significant funding and significant orders for our first unit, we're the team's now at about 10, and we're sort of trying to double that team over the next 12 months as well. So we're expanding pretty fast now. So it's pretty exciting times.
So it's an Australian developed product.
Yes, yeah,
right.
Yeah. So one of the only sort of all-in-one systems that actually has been designed in Australia from the ground up. So we're pretty proud of that.
You're not just sneaking in someone else's inverter and sort of calling it yours by putting a box around it.
No, exactly. So some of our competitors, won't name names, but we haven't just bought a Chinese inverter and stuck it in a box or whatever. We've really designed it from scratch, and there's good reasons for that we'll talk about a bit later.
Yeah, I mean, I've seen the product. I've been to your manufacturing facility, or your R&D facility, and it's definitely a bespoke piece of equipment that you've designed. I must admit, I was pretty impressed that you've come at it from first principles, really. You haven't gone, everyone else makes an inverter this way, we'll just make one the same, or we'll just pick apart someone's circuit board and do it. You've come up with some really innovative solutions to things like thermal management.
Yeah, exactly, yeah. So I think we looked at what was out there, and we, as I said, sort of really tried to look at whether it could provide the services that we need it to, and we found a lot of them wanting on, as you say, on thermal management or on software control flexibility. So we couldn't find something that encompassed everything all into the one product. We had to design our own.
Wow.
And that's how we've come full circle to here.
Yeah, I've got a few questions here, and I was kind of referring to them. So, like, I wrote down here, why another all-in-one inverter? I mean, we've got quite a lot on the market. Why do you think customers need mPower's solution?
So I think firstly, to touch on the all-in-one side, we really think that that's the way forward for a number of sort of techie reasons that we can talk about later. But yeah, I think all-in-one is the way to go. For efficiency, for lots of other reasons, but primarily it's cost of ownership of the battery system, the PV system, and being able to control everything in one place. We see a lot of value in that, and we think selling VPP services is really where that value lies in the future.
Right. So, like you said at the beginning, the software and the intent to go down the VPP path drove the design of the unit. I mean, what's special about it in terms of VPP?
So being able to control the battery, the solar, and everything all in one is the big thing. If you just buy an inverter off the shelf, for example, it might not be able to provide FCAS services. So we can design FCAS response into the hardware platform itself and make it faster than everyone else, for example. And we can adapt to Australian standards and requirements specific to Australia as we need to.
I just realised I used a couple of acronyms we didn't explain.
Yeah.
So virtual power plant, VPP. It's not really a power plant. It's an aggregation of lots of small systems.
Yep.
And FCAS, frequency control and ancillary services, which is really a package of services, isn't it?
Yes, yeah. So there's a whole heap of grid services that can be provided, and we're, to be honest, fairly early in our life in terms of being able to provide those services. But the key thing is we've designed that platform to be flexible.
Now, when it comes to response time in a VPP, you've got to get a signal, don't you? Like, now's the time to import energy or export energy. The speed of that response, I believe, is important.
Yeah, so for FCAS in particular, that's correct. Yeah, so you actually measure the frequency locally to the unit and respond as fast as you can to that frequency response. And the faster you respond, the more you get paid effectively.
Wow.
But then there's lots of other services that would rely on an API type communication to the cloud. So there's a whole host of
so it can
services.
Be intrinsic to the unit, just actually measuring grid frequency, or
Correct.
it can be called upon through an API.
Yeah.
And if it's called upon by an API, then you've got communication delays.
Correct.
How do you solve that one?
You just operate as fast as you can.
Yep.
So, for example, we've got Wi-Fi connectivity and 4G connectivity. So our latency is something around a second. It varies quite a lot depending upon various scenarios. As you know, here we're at the top of a mountain where you're connected up to satellites, so you might have slightly higher delays. I'm not sure, but basically we're looking at around a second.
Right, from an API request to you're actually doing something with energy.
Pretty much, yeah. So It varies quite a lot, but that's the sort of order.
Oh, okay. Yeah, it's new to me what that value is. Like you said, the faster you respond, the more you...
For FCAS.
For FCAS?
Yeah, for the VPP services side, it's this is a whole evolving industry, so I'm not sure on the speed, value, time, and it will change over time a lot, but it's not as important.
Sorry, I was packaging them together and I didn't mean to do that. So with VPP, it's about aggregating small systems to effectively be a bigger power plant.
Correct, yeah, and retailers can use it to hedge, so they can buy and sell en masse, and then grid services, the networks, etc., can use it to support the grid. So if the volts go low, they can sort of manually set 1,000 units to discharge, for example, and try and support that grid voltage.
Right.
So yeah, there's a whole heap of complexity, and the market's constantly evolving in this space.
Cool.
So yeah, but it's only going one way.
What's that?
Well, VPPs are going to be huge.
Yeah. So let's dive into the product directly. Let's have a look what's inside in terms of its features. Now, I've got the data sheet here. I see that it's got dual MPPT.
Yep, so we've got two MPPTs, both at sort of 2 by 4 kilowatts. So 8 kilowatts total is, about... where we're at.
And it really suits to have the high current modules. I was just looking at the MPPT window. So it looks like using like your modern 400, 410 watt modules with a relatively low VMP, but a high current, you'll get to 4 kilowatts with just 10 panels.
Yes, yeah. So we've got quite a few installs in New South Wales at the moment with that configuration.
So 2 strings of 10, but being dual MPPT, you don't have to match the strings. You can have 9 and 10 and a 6 and 10.
Exactly, yes.
And it'll go down to 150 volts start and 100 volts while operating.
Yep.
Right. Oh, so it'll work with like 3 panels virtually.
Yeah, it'll work down pretty low. Yeah. So it's been. We've got 12 units currently installed in the field, and they've been running now for about 6 months. We're installing 100 units over the next few months, and then 1,000 over the next year. So it's.
Now, when you say we are installing, so does Empower install?
No, we've sold the units wholesale effectively. Yeah.
Right. So you've got a sort of a installer network who install your products.
Yes.
Yeah. So they're available to the market now. Like people can order them and.
Yep. I can send you a link.
So it's a B2B process. You're not selling to the customer.
We're not selling to the end consumer. No.
Yeah.
No. We're selling B2B. That's right.
Okay. Cool. In terms of the battery, tell me a bit about the battery technology inside here.
So we've got lithium iron phosphate, which is one of the safest lithium chemistries. So we've configured it into 6 different modules, so they're easy for the installer to lift and install. So the unit itself fits onto the wall first, and then the 6 different modules slot in once the unit's on the wall.
How heavy is the unit without the batteries?
Unit's about 55 kilograms without the batteries, and then each module is 20 kilograms.
Right.
So once you've added 6, you're up at about 180 kilograms for the unit.
Can it be floor mounted?
Yes, it can be floor mounted. Most of our installs are wall mounted. We've got a nice wide wall bracket that can span across vertical beams. So we haven't had any issues yet wall mounting, but floor mounting is definitely an option.
What's the width of the unit?
It's 900 wide.
Okay, so exactly like 2 studs, typically 450 studs, or sometimes 600. So yeah, okay, right.
Yeah, so it's 1.2 meters tall and about 250 millimeters deep.
Why do people mount it off the floor? What's the reason for that?
I think often it looks a bit nicer, in my opinion, off the floor. Also, you get less animals crawling around and less muck and dirt around. It's easier to clean, I think. So yeah.
Speaking of animals, well, let's say insects probably. Can they get inside the electronics?
No, so it's an IP66 sealed unit, which is fairly unique in the marketplace. There are some others. But we've really worked hard to make it a product really designed for Australia. So it's really sealed from dust and from water. So we don't want moist, salty air blowing over all of the electronics. And, PV inverter companies learnt this 20 years ago. We're seeing quite a few battery manufacturers come out without IP66. So they're actually blowing that nasty Australian air directly over some electronics, which I'm not a fan of. So
especially if you live in the northern beaches at the moment.
Exactly. Yeah, it's pretty wet right now. So really took that stance from the outset there. And as well, it's an aluminium enclosure. So again, I'm not a big fan of steel enclosures and cars throwing up stones and steel enclosures corroding over time. So we've spent quite a bit of time and effort making it a really durable unit. Right,
so you're not relying on the powder coating to keep the durability. It's actually intrinsic to the material.
Correct, yeah.
When it comes to active cooling, though, I mean, if the unit's getting hot, how does it cool itself if it's IP66?
Yeah, so as you allude to there, sort of why lots of people haven't gone down the IP66 route is because it's much easier to blow cool air over the batteries and cool them down. We've taken the approach instead to use a heat exchanger. So we're using an air-to-air heat exchanger to keep both the air electronics, but even more importantly, the batteries cool, so their lifetime is significantly improved. So yeah, to get around the IP66 problem, we're using a really nice little heat exchanger.
Let's have a look at the heat exchanger on the CAD you've got here.
Yeah, so it sits basically in the back here. So if I hide the enclosure, the heat exchanger sits in the back here. So air is pulled into the back here through the heat exchanger fins here and up over the big inverter heat sink. So that's the external air loop, and then the internal air loop is on the inside here and sucks air through the inverter, cools it, and then blows it up and over the batteries.
So there's no path for external air to the electronics or the batteries.
Correct.
The heat exchanger just bridges both sides of that internal environment, external environment.
Exactly. Yeah.
And it's got an active fan across that exchange.
Yes. Yeah. Exactly.
So it moves the air around.
Yeah. So there's an internal fan that forces the internal loop, and we've got two external fans for the external loop there. We've been seeing really nice field performance with the batteries really staying nice and cool.
Right. Now tell me a bit about the batteries. Are you allowed to say who make them?
So CATL make the cells. So they're one of the biggest. I think they're actually the biggest.
I think they are the biggest.
LFP manufacturer in the world now. Tesla and BMW and everyone are using them. So yeah, they're really high quality, reliable cells. So we've been it's been a really good choice to go with those guys, I think. And so they're 100 amp hour cells, and in each module here we've got 8 cells in series, and we series them all up. So in total we have 150 volts. So in my mind, this is another sort of significant advantage that the all-in-one product brings, is that we can series all these units, all these modules up, get to the higher voltage, so we can get the current down and the efficiency up, so that we don't have to transfer high voltage from a separate battery system to an inverter.
So you're saying that the 154 volt cells, are they in series with the other 154 volt cells, or in parallel? Not cells, battery modules.
So each battery module is 25 volts.
Oh, I see.
Because there's eight cells at 3.2 volts.
The big cells, the 100 amp hour cells.
Big cells, yeah, exactly, yeah. So roughly 26 volts per module. We series them all up to get roughly 150 volts.
Gotcha.
And then that sort of, compared to, for example, a 48 volt DC system, our efficiency can be higher.
In terms of a BMS, is that integral to the battery modules?
No, so we've designed the battery management system ourselves in-house. Again, to really, we started out, we bought one in and played with it and all the rest of it, but we really found that being able to design our own increases the reliability of the product and the flexibility, so we can accommodate different battery modules if we need to, for example, not in this specific product, but in the future. We've designed our own battery management system. So that's under here. So there's a master which sits down here, and that's got a big safety relay connected to it, and then we have multiple slave systems that sit off the master.
Now, this would be described as a DC coupled unit, in that you've got PV coming in, and you can charge batteries with that PV directly.
Correct.
So one of the issues I've had here at the lab is if I turn off a system for a while, and often the self-use of the system, when I say turn off, it's not providing any services, but it's still running its electronics. The batteries go down and they'll shut down. Sometimes that's basically a recovery effort to get them to turn back on again, because there's no way of charging them once they go down too low. The inverter turns off. With an AC coupled system, I can't charge those batteries anymore. Is that a problem or not with your design?
So I mean, that's a problem for all battery systems, right? Yep. But so we turn off the battery cells at I think it's sort of 2.8 volts, and then they can keep discharging down to 2.5, but that will take, I don't know, a couple of months, I think. So, but regardless, when the sun comes up the next morning, this system would just self-charge the batteries back up. Right.
So for I should have mentioned this at the beginning. This is an on-grid hybrid system.
Yes.
All-in-one PV, AC output, backup, batteries. got all those goodies. And if you are having extended blackout, like many people have in Australia recently with all the storms and floods, and there's no grid for a week or two, it's not a problem. It'll still just come back to life again.
Exactly, yeah. So in the mornings, when the sun comes up, the PV will charge the batteries straight away,
Yeah.
and try and keep your house loads on as much as it can.
Right, cool.
So yeah, it's got 14 kilowatt hours of battery, which is pretty large. So it'll be able to keep most houses going in a blackout for a fairly decent while.
It does seem to be the magic number. Many systems are in the 10 to 15 kilowatt range. Why do you think that is?
So I think that's generally at the high side of what the majority of the population want, but at the moment we are seeing it's mostly early adopters getting batteries, and they often have bigger houses, for example. So I think that's why. But in our mind, this is a really good size, because I think whilst it might be more than a lot of people need, I think the excess we're sort of planning longer term will be used for VPP services. So the customer can still get returns on that excess battery that they have sat there. It's not wasted.
Yeah, so that's always the consideration. If you oversize your battery and you don't use it, you've wasted your money. So you've basically got this big battery, it's only used 50%, but with VPP and F-gas as well, you can start to use all of that. So VPP is the most likely scenario, I suppose.
Exactly, yes.
Wow. Yeah. Okay, so yeah, it's really it's kind of a financial device. Like, it's actually making money for you as well as making energy.
Yeah, exactly. So that's sort of comes back to the starting kind of the founders' intent. Is it's really about value, and it's not just value for the consumer, although that's our sort of main priority. It's value for retailers, networks, the grid as a whole, the whole energy system. Cool.
So let's look at your Prezzo here. This is kind of introducing the company in a bit more detail than we did before. So tell me a bit about the timeline.
Yeah, so the company was founded in 2010 by the managing director. And then, we were been awarded a commercialisation Australia grant back in 2012, and that enabled us to start developing the first product. And then I joined back in 2016, roughly. We really started to develop the ElectroBank 7, which was our first product. We installed a few of those on some walls, and basically that enabled us to really focus on the new development of the ElectroBank 14, which is our latest and greatest.
So the first iteration was an all-in-one as well?
Yes, it was. Yeah. It basically enabled us to learn and develop a lot for the latest product.
Cool.
Which we've just certified to the latest 4777 a few months ago now. So
the 2020 edition, 4777.2 2020, and you didn't have any of the DC isolator problems that other companies have had. Why is that?
No, so we decided not to put a DC isolator into this product, which turned out to be a good decision for some various certification reasons. But
talking of isolation, typically you're going to have an external DC isolator. Mm-hmm. Do you need an external AC isolator as well?
So if you're within 2 meters of the switchboard, no, you don't. If you're beyond that, then yes, you do.
Okay, cool.
So Empower really envisions a world run on 100% renewable energy, and we really see every household, business really being empowered to generate, store, consume, and also sell their own energy. We really think there's going to be a marketplace for that. So our mission is to really provide the best value battery storage solution on the market that enables a greener, more reliable, and lower cost distributed energy future. So we really want to enable people to buy and sell energy as they want to, and as supports the grid.
Fun fact, my other company is Solar Plus, which is a software design program. We sell this as a design tool for companies that sell solar. Mm-hmm. We've noticed that 25% of all quotes now include storage.
Oh, wow.
So
That's a big hike.
It's really, really big. And of course, Australia's got the highest per capita installed solar capacity in the world. Basically, everyone who's got a solar system will eventually want a battery to go with it. Or if they haven't got either, they probably want an all-in-one. They want solar and batteries. Yeah, so exactly. You're right. It's going to be, every home will be, I call it the autonomous home. It produces all the energy it needs to run itself, and the financials can work out. And some, and the financials can make it, the no-brainer. You don't have to sort of think about it as, I'm just doing something good for the world.
Exactly, yeah. And I think over the next few years, we'll really see the economics start to shine through here.
Cool.
So in terms of our mindset, we've really tried to design a minimalist unit. So we've really tried to reduce all of the cost out of the unit, but not just the unit, the system as a whole. And we've really tried to make the install simple for the same reason. Sparkies in Australia aren't cheap, so we want to minimise their time on site. We also have aimed for zero maintenance and high reliability. So we don't want consumers having to hose this down too much or any of that, right? So it's,
But they could if they wanted to, because it's IP66.
Exactly, yeah. Although we're not allowed to put that on the data sheet, apparently.
What, hosing it down?
No, apparently not. So as I sort of talked about earlier, it's about enabling the smarts, this. So we really want high performance AI, so we can really optimize the charging and discharging of the battery for the consumer, for their bill, and to enable them to get value from the whole product.
So how does that, AI is a fancy word, artificial intelligence. What is that intelligence?
Yeah, so basically we want to be able to predict the solar for the day. Mm-hmm. We want to be able to predict the user load profile for the day. And then we want to be able to optimize the battery to charge and discharge to minimize the consumer's bill. So we really want to reduce their bill as much as possible. So that's the sort of first task. And then above and beyond that, we also want to be able to respond to grid events. So if there's a high electricity price, we want to make sure there's enough stored energy in the battery to be able to sell at that really high price and make money for the consumer and make the battery pay back in a much shorter time.
So where do you get those inputs, like solar forecasting?
Solar forecasting, we go off the BOM,
the
weather forecast, and we trend out the historical data. And the same for load profile, we trend out the consumer's historical load. And then for grid, the AE may provide a forecast for the next day, et cetera, et cetera. So there's a few different methods there.
Right. So in terms of the BOM, it's not like you looking up to see the forecast tomorrows and typing something in and all.
Not quite.
No? It's a bit more automated than that?
Yeah, so there's APIs where we pull all this data down for the local address, for example. And then we apply the sort of cloud intensity forecast against the historic PV generation from that consumer and trend it all out. There's some smart stuff going on, but we're learning a lot and constantly evolving that system. So we're still in the early days with it, but yeah, it's looking good. So
let me get that right. You've got solar forecasting, you've got load forecasting, and you've got grid forecasting as well in terms of price. Anything else from the grid that you would forecast?
So the grid forecasting is a future benefit, but it's all sort of built in, so we can start to look at that. For now, we're just focusing on the consumer bill optimization.
Right.
And that should give roughly. It's very hard to generalize this because consumers are very varied, both in PV and in load. But we sort of expect to see a 20% improvement once we turn on the optimization service. So 20% further reduction in the consumer's bill.
Cool. Okay.
In our mind, it's really about trying to optimize the whole system for the installer, the owner, the grid, the market, the whole energy ecosystem, if you like. So we've sort of really taken the approach of stepping back and designing from scratch here. So we've, as we talked about, the all-in-one design to streamline all of the installation, and provide a single point of software. So you might have, with some other systems, you might have 4 different boxes on the wall. We've gone for one, so that you only upgrade one box and everything works seamlessly. Yeah.
Speaking of that, is that over-the-air firmware upgrades?
Yeah.
Right.
Yeah.
Wow.
We're upgrading. Quite frequently. Primarily, just on the software optimization side, because the standards define a lot of the main operation of the unit.
You can't change the safety settings.
Correct, exactly.
Yeah.
So the flexibility for us is huge. So really making everything upgradable. Adding grid services over time, adding more feedback for the consumers, so they can see how much they've saved, how much better they're doing with the optimization service turned on, for example. We're all local, which is quite unusual. So we're constantly learning. We're got quite a few products in the field now. We're getting a lot of feedback, constantly improving. It's exciting times.
So if I'm the lazy installer, as I sometimes are, and I open the box and there's a bracket here, I guess I'll stick that on the wall, and there's a quick start guide, I presume.
Yeah.
And so I just start installing it, and then I get to the point where, what do I do next? Is there an Australian contact that I can ring and go,
yes, me.
Yep, it's James, right?
At the moment.
And do you use the phrase, have you read the manual?
More times than I can possibly remember. Every installer needs to learn to read the manual, in my opinion. No.
Maybe it should be a little prize at the end, like, you read the manual, you answer this question, and you get a lolly or something.
That's a good idea.
Yeah.
I might add that. Yeah, that's a good idea.
Cool.
Yeah.
So it's local support, local design. What about manufacture?
Yeah, so we are manufacturing in Malaysia, but we have a contract manufacturer that's actually Australian based. So we do some in Malaysia, some in Australia.
Right.
So it's a bit of a mix.
Say you have a faulty battery, which is pretty unlikely being cattle, but what do you do?
So the installer would be the first port of call, and then he'd probably ring me for that sort of thing. Mm-hmm. And then we would just initiate a replacement battery to be sent out, and it'd get changed pretty fast.
Cool.
We haven't had any yet, so
yep.
Not sure exactly how that process would work, but it would, it's pretty easy. Yes, especially as the batteries are all modular. So we have a 10-year warranty.
Mm-hmm.
But yeah, so
you have an energy throughput warranty too, don't you?
Yes, 45 megawatt hours, I think.
Yep, that's what I read. Yeah.
Yeah.
Unless it's an old data sheet.
I've written all these numbers, but my memory isn't so good. So there's too many numbers flying around in my head.
Cool.
Yeah. So the product evolution, as I sort of said, we started in 2015. That was before I started. And then we moved on to the ElectroBank 7, which was 7 kilowatt hours. And now we're on to the ElectroBank 14, which we are discussing now. We'll skim over this one. So in terms of the ElectroBank 14, we're at sort of 5 kilowatt grid interactive inverter with 2x4 kilowatt MPPT inputs. So 8 kilowatts total. So if your battery's not at 100%, you can charge the battery at 5 kilowatts and still be exporting at 3 kilowatts out of the unit, for example.
So the 5 kilowatts is DC input to the battery, and you've also got an inverter function which can be additional PV power to that.
Correct.
Okay. Yeah, so hence oversizing isn't trimmed. It's not like 8 kilowatts gets trimmed down to 5.
Correct, no.
All 8 can be used if there's capacity in the battery.
Exactly, yeah.
Right, so it does incentivize having a bigger PV system, which is what everyone wants. In fact, I think you're right on the money at the moment. The average PV size from the last stats I saw from the CER is 8 kilowatts, or 7.8 or something.
Yeah.
So you're right on the average size now.
14 kilowatt hours we chose because we think that's the optimal size for a lot of consumers at the moment. Mm-hmm. And I think while it's a little large for some consumers, I do think by oversizing that you future-proof yourself, A, but B, any excess battery capacity in the future can be used for VPP services, again increasing the value for the consumer. We have an integrated backup circuit as well. So if the grid goes down, we can supply up to 5 kilowatts on the backup circuit.
How does that backup work? Is it like turns off for 30 seconds, then turns on, or?
So it's fast backup. So you'll see a very quick flicker and it'll come back up.
Right. Okay. So more or less instantaneous.
Correct. Yeah.
Yeah. And in terms of overload capacity, like, is it hard 5 kilowatts? It'll take a little bit more than that.
It'll take a little bit more, but we tend to recommend don't put 5 kilowatts on your backup circuit, because it won't last very long if the grid goes down, because you've got 14 kilowatt hours of battery, so it would only last for 3 hours. So we tend to recommend consumers put a fridge and a few light circuits on. That's often good enough.
Yeah, unfortunately that advice doesn't often get through to
No.
some installers, and
I know.
the whole house gets put on the backup circuit.
Yeah, exactly. Yeah.
Including me, I managed to do that the first time I did an off-grid, a backup system, and the customer decided to bake a cake when the power was off in the street. It didn't last long.
Yeah, exactly. Yeah, so we tend to use a contactor on the backup circuit, and that's a really nice way of configuring the backup, and we can maybe talk about that a little bit.
So
later.
you mean an internal contactor or an external contactor?
An external
But you have
contactor.
the ability to internally switch as well.
Correct. So we do have internal relays, but we tend to recommend an external contactor. It's often easier to wire it into the switchboard, and also
How do you control the contactor with the
grid volts?
Okay. So it's an ATS, right?
Yeah,
so the grid
exactly.
fails, it goes into one position. The grid's there, it goes into another position.
Yeah,
and
which is the same as what the unit does.
yeah.
But it's if the unit has a fault or the circuit breaker goes in the unit, then it's annoying for the consumer, right?
Right. So this is a case where if anything, which is very unlikely, happens to your mPower unit, with an external contactor, you still have power on that backup circuit.
Exactly. Yes.
If the grid's present.
Correct.
You're not reliant on the brain inside the mPower keeping it up.
Correct.
Yeah. That is actually a really important consideration. Like, things do fail, and
fridges need to stay on.
And if you have to get an electrician out to rewire your switchboard so you can carry on running your fridge, it's a bit of a problem. Yeah. Okay. Cool.
We've talked a bit about the IP66 enclosure, but that's really key for Australia, especially all along the east coast. You've got so many houses next to the sea. It's crazy.
Now, you've got there operates at high temperature. Can you be more specific?
Yeah, so the lithium-ion phosphate cells operate up to 55 degrees C, so that's already that's the actual cell temperature. So temperature gets tricky to talk about with battery systems, because there's a lot of thermal mass inside the battery. So people ask, so how hot can the battery run in terms of what's the ambient temperature? It's a very hard question to answer, because it really depends on the load profile. So how fast is the battery charging and discharging? What's the solar doing? And the thermal mass of the battery. But basically, in all of our installed units so far through the whole summer, admittedly it's been a pretty rainy summer, we haven't seen any derating power at all, which has been really nice to see.
So would you say do not install in direct sunlight?
Yes, I think that's just good practice for any battery unit.
But otherwise, outdoors in Australian summer, no problem. Just not in direct sunlight.
Correct.
Okay.
Here we've got a typical install from potentially some of our competitors. So you've got your battery unit that is either AC or DC coupled in. You've got your solar inverter through a subboard and potentially to a backup gateway. So we've really sort of taken the approach of why are there these three different boxes on the wall. I don't personally understand how the industry has evolved that we've ended up with these three boxes, and I've sort of taken the approach at the start we should combine them all. There's similar electronics in all of these boxes. There's DC caps in the solar inverter, there's DC caps in the battery storage. Why can't we put it all in one as standard? So yeah, really tried to simplify everything.
In terms of that, the gateway or the changeover switch, I mean, what we've said before is you could put an external automatic transfer switch into a switchboard, but you need to control that. So you're going to run just an AC cable to it to control it, or a comms cable?
Yeah, so the simplest way is to just put the grid volt straight onto the coil. So the grid volts itself controls
yes. So
the ATS.
You're taking the backup circuit to your, hopefully your main switchboard or the subboard to which you want to back up. You've got a grid supply from the main switchboard to the ElectroBank.
To the coil? Oh, sorry, yep.
Yep. And so there's basically two AC cables. There's no comms required.
No.
Right. The comms actually are built into the unit itself.
Correct.
And that's you've got wired and wireless.
Yes.
So you've got Wi-Fi, Ethernet, and 3G, 4G.
Correct. Yeah. So the reason we've put the 3G, 4G in is really for the VPP availability. So if the grid goes down, we want to ideally try and stay connected so that we can, so the consumer can still see what's going on with the backup circuits and all the rest of it.
Does the customer have to buy the SIM?
No.
It comes with it?
Comes with it, yeah.
Right, okay.
Yeah.
I guess there's not a lot of data transfer, so it's...
No, it's pretty low data.
Yeah, low data, yeah.
Yeah.
All right. Does that also transmit to the cloud for monitoring?
Yes. So I can show you a few dashboards, and also we get a lot of data back from the unit at sort of 5-second intervals. So there's a lot of data that we base all of the optimization services on.
Is the warranty conditional on that connectivity?
Yes, you do have to have internet connectivity. I mean, yeah, we're pretty flexible on it dropping out for a few days here and there.
Yeah.
But and we'll support helping people get the unit back online for example. But having the 4G present means it's very unlikely to actually drop off ever.
So it means that you can identify faults before the customer knows it.
Correct.
Should you choose to do firmware upgrades to things like the optimization, you can do that remotely.
Correct.
There's monitoring for a customer. Is there monitoring for the installer, like a different level of monitoring?
Yes, exactly. Yeah. So we have this. We call it a fleet manager.
Mm-hmm.
And this is where we can see all of the installed units, and the installer would also be able to see their installed units and help to debug. So yeah, if any faults happen, that they pop up on here, and we've got this on a big screen in our office, so we can respond pretty fast.
Sounds like you're going to need a bigger screen.
Yeah, exactly. But yeah, this is really nice. It's an awful day to be looking at solar in Sydney today.
Yeah.
We normally see this up, but
is that 9.4 kilowatts? Is that one system?
No. You'd think so, wouldn't you? No, it's unbelievable. I'm glad I'm in sunny Melbourne today.
The weather's always better in Melbourne. All right. Well, since we've started talking about the dashboard, do you want to just run us through, have you got a view that the consumer might see?
Yeah. So if we go to the owner website here, so this, for example, is a view for the consumer.
See that little there? Just click on that. Yeah. It makes it a bit bigger. Yep.
So as you can see, it's a fairly low solar day here.
Mm-hmm.
But this consumer, for example, is very self-sufficient. So if we look over the week, batteries in blue, solar's in yellows. So this is the energy usage used by the home.
Mm-hmm.
So he hasn't had to
buy the grid?
Any grid.
None.
No. So he's completely self-sufficient. So he's got a pretty small house with a lot of solar, not much load, and a nice big 14 kilowatt hour battery.
Wow.
So he's doing really well.
I'm looking here, they're peaking at around about 12.5 kilowatt hours per day.
Yeah. So
of energy shifting. Now there's a little bit of grid there.
There's a tiny bit.
Yeah, right.
Back there when it was a very rainy day, and after a few days like today in Sydney, you might use a little bit, but it's pretty low. And then you can compare that to someone else, for example, who uses a lot more grid.
50 kilowatt hours a day. Ooh.
Yeah, I don't know what this guy's doing. I think he's.
So you got foil on the windows?
Quite a big family, I think.
All right, okay.
Yeah. There's a whole heap of different users and user profiles.
I shouldn't be so judgmental. I'm a very big energy user, mainly because of electric vehicle charging.
Oh yes, yeah.
So, you know,
and Bitcoin mining apparently.
Shush, yes. Sometimes, but yeah, it's mostly about charging electric vehicles because, you know, it's free. It's solar, it's free, and it feels good with petrol prices going up. Yeah.
So there's some really interesting things that will start to happen with EVs as they become more prolific in terms of integrating with stationary storage. How do you know? So we're trying to optimize the battery charge and discharge, right? How do you know what the EV is going to be doing? Somehow you have to be able to predict what the EV will do. So, you know, in the future, we're going to be linking up very closely with the EV systems and supporting them when to charge, when to discharge, and optimizing the battery to be able to minimize the bills for people with EVs and try and predict when they're going to work, when they're coming back, that sort of stuff. So it all gets very advanced.
So how will you do that? Like, how will you know when the car's there or not?
Well, you might be able to predict if it's a daily cycle. You can predict the load.
Oh, so you're looking at the supply to that circuit. So
correct. Are
you doing disaggregation of data, or are you using a CT?
We're using smarts to basically when we install, we would ask if they had an EV, and then we would be able to figure out when they were charging.
Yeah.
Charging it or
like
not. It gets tricky. It gets tricky.
You see a thumping great 7.4 kilowatts
exactly.
come on.
Yeah. So you can do smart stuff like that. As well, longer term, we will link up with the EV chargers and via APIs, for example, and learn what they're doing and all the rest of it. So there's a whole heap of work that will come in with EVs in the future.
It's a huge disruptor. I mean, it'll be the biggest battery you ever own will be your car. Well,
exactly.
It is in my case. So 64 kilowatt hour battery in the car is pretty big for a home battery system.
Yeah.
Now, going forward, I mean, we're just starting to see bidirectional charging happen. So we've now got, one product, I think, on the market in Australia, but probably more to come, that can do bidirectional. There's still a bit of a hiccup with what type of connector you've got. You know, CHAdeMO, yes, Type 2, no at the moment, but Type 2 is coming. But once you've got your, let's jump forward 5 years, bidirectional charging will be pretty normal. How will that be used by your smarts, your optimization?
Yeah, so I think lots of the time the car won't be parked there in the middle of the day because people will drive to work. So the battery will charge up on the excess solar and then be used by to charge the EV at night potentially. But yeah, there's a lot of smarts that will get built in around EV charging and the ability to optimize the energy both for the consumer and for the EV.
I guess my question was a little bit of a Dorothy Dix because I kind of thinking that in a way inverters are the center of home automation. You've got connectivity to the cloud, you've got optimization, smarts, exactly. And whatever energy demand, loads, generation that come into that mix, you've visibility over it.
Yes.
And it doesn't really matter if it's third party like a car.
No, exactly. So we can either predict what the EV may or may not be doing, which is a bit tricky, or we can link into the API from the charger itself, or possibly the car longer term, and be a bit smarter there. So there's a lot of different options. But yeah, the Elektrobank unit will be the energy center effectively of the house and learn everything.
I know my car, which is a Hyundai Kona, it's got a SIM and it's 3G connected. Unfortunately, it's Telstra and we've got poor Telstra reception here. But when you're in a Telstra area, we can see it on an app. But presumably an API will be able to communicate that to third parties.
Exactly, yeah. And longer term, you can start doing really clever things with EVs.
Cool. Should we go back to your presentation? We just jumped over to the customer dashboard. Maybe we'll come back to the installer dashboard later on.
So this is an example of an AC coupled battery storage, similar to the one we looked at on the last page here. And this is really just showing that we can cover a lot of this.
So everything in the yellow dotted line is actually
unit.
Built into your system.
Correct.
To the Elektrobank. Yep.
So this is just some installs that we have in the field. So I've been to all these sites and supported these for the initial rollout, which was
There's a logo
really
lit
exciting.
up.
Yeah, the MPAL logo lights up with an LED there, so that's
Does it do anything like change colour or
yeah.
tell you stuff?
It changes colour, so if there's a fault, it changes colour.
Yep.
And yeah, if you're in backup, it blinks at you to let you know the grid's gone down.
Yep.
So yeah.
And say you want to know the capacity of your battery, what ways can you find out? I mean, in terms of usable that's left in the battery.
Yeah, so you would log into the user website, and we're designing an app at the moment as well, so there'll be an app shortly.
Oh, okay, cool.
So yeah, we've got sort of quite a few installs in a garage here, and then this one's outside as well. This guy has a big external solar at the moment, so we've plugged in, I think, 6 kilowatt into our unit, and he already had 6 kilowatts on the roof as well, which is why you can see the external solar as well there.
Can you have more than one?
Yes, you can install 2 of these. So the general rule, you're more across the rules than I am, is 5 kilowatt.
You mean the utility application process? Let's say you're a 3-phase home.
Mm-hmm.
You've got plenty of capacity. So
yep. So you could have 3 of these, 1 on each phase.
Yep. And if you were given a exemption for a certain amount of export, a certain amount of self-use, could you have 6 of them?
Yes. No reason why not. We haven't tested that yet, so we would need to trial that. 6 is getting quite large, but there's no difference. The grid is the grid. So
I'm just looking at the form factor. You could do 2 high and 3 wide.
Yeah, exactly. That would be nice. A little matrix style. Yeah.
Yeah, I'm happy to help there if you need a space. I've got a little spot out there.
That would be good.
But yeah, I guess what I'm saying is you can scale it for those who need more storage. But the bonus is you actually got more PV inputs, whether you need it or not. So you can AC couple them? Like if you've got 2 of them, are they going to work together or?
Yeah, so if you had 2, you could plug PV into one of them and then just AC couple the other one.
Right.
Yeah.
So how does the one without PV know what the consumption is on site?
Yeah, so we have, it's on the data sheet. If we open up the data sheet, you've got the data sheet there. If you go to the first page of that one. So we have a meter installed at the front of the house.
Yeah.
So we're constantly measuring the consumption of the house. So the battery would charge and discharge. So the normal mode is to maximize self-consumption, where we're looking at that at the house consumption. We're trying to make it 0 because there's no point buying electricity because you don't want to pay for it, and there's no point selling electricity because the feed-in tariff is so small. So the normal mode is to maximize self-consumption. But then above and beyond that, we have our optimization service, which runs a bit smarter than that.
So your Elektrobank energy meter can allow you to AC couple more systems to be able to charge, even though they don't have PV connected to them, because they can see the surplus.
Correct. Yeah.
I gotcha.
We also connect another meter to the PV inverter, so but that's purely for viewing purposes for the consumer. So the consumer can see their PV generation from a separate system.
So third-party PV inverter, not the one built in.
Correct.
Okay.
Yeah.
Oh, right.
Yeah.
So is that a CT or is it?
Yes,
it is. Okay, so I'm just thinking about cable arrangements here. So you've got to run a data cable from the main switchboard where your ElectroBank energy meter is.
Correct.
Back to the ElectroBank itself.
That's right. Yeah.
Can you do it through comms? Like, could you have a?
Yeah. So we started out, a few years ago. We tried Zigbee. We tried a few other things, I think the fact that you're running a grid cable to the ElectroBank unit anyway means you might as well run a data cable. It's more reliable, it's much more robust. So that was the decision we've taken off after a few issues with some wireless comms.
Yeah. You just got to consider segregation because it's a communication cable mixed with power. You've got to segregate them. But you're going to be crawling through the same space or poking things through the same wall cavities. So,
exactly. Yeah. There's a comms cable you can run in the same conduit, right?
Well,
is that getting complex?
It gets a bit complicated because AS3000 describes segregation on voltage. On extra low voltage, like communication cables. You can use a partition. It can be an insulated partition, or it can be an earth partition, or you can use space, 50 mils of space. But if you're running DC and AC, then 5033 requires them to be segregated as well. So if you're bringing PV down that same path, you're going to have to segregate the PV DC from the AC, and that the insulation of all cables must be that to the highest present. And if they're on a conductive surface like tray, then you've got to earth the tray, etc. So it's not quite as simple as just jam it in a bit of conduit and hope for the best. So make sure you comply with AS3000 and 5033 when it comes to segregation.
As we talked about at the start, we've designed all of the electronics in-house, so we've really taken the approach of simplifying the system. So less interconnects between all of the different boxes, etc., fewer parts. So by putting everything in the one box, we've improved the reliability of the whole system, we think, by having fewer parts there. And the unit's really been designed to be autonomous. So we load a profile, a schedule into the unit, and if there's any internet or grid dropouts, the unit will sort of keep running autonomously. 10-year product warranty and a 45 megawatt hour throughput warranty as well. And as we talked about earlier, we've gone for the full shebang of powder coated aluminium enclosure. So it's really a premium product. In terms of its lifespan. Yeah, really designing for harsh Australian. What about the cell life? Like, is there any fade in capacity over time? Yeah, so cycle life depends a lot on temperature. So these cells have a pretty long lifetime rating. So at 25 degrees C, 90% depth of discharge, which is all we allow them to go through. They can go 6,000 cycles and maintain 70% of their capacity over that time. So that's about 16 years, assuming one cycle per life. Though it's a 10-year warranty or 45 megawatt hours, whichever comes first. So that's the warranty. So let's go 10 years, if that comes first. You could probably cycle twice a day then. Exactly, yeah. Right, so that's where the VPP comes in. Yeah, so you can potentially get some value from early morning and doing a double discharge throughout the day. There's probably not a huge amount of value in it right now, but we see over time that value will increase significantly. I'm just thinking about the charge rate. What's the C rate for charging? C rate is, so it's a 100 amp hour cell, and we can charge at 32 amps. Okay, so 0.33. Yeah, gotcha. All right. So it would take about 3 hours to charge, roughly. At 5 kilowatts. At 5 kilowatts. So especially if you've got 8 kilowatts of solar and it's not a rainy day in Sydney for a change, or anywhere else in Australia. So charging about 3 hours, then it's available for self-use or VPP. Then you've got possibility of charging again. Exactly. So, right. So certainly in summertime with longer days. Great. Yeah, and then we've got the heat exchanger built in, which is really good to keep those cells as cool as possible over their lifetime and extend that as much as possible. Does the heat exchanger use much power? No, the fans are sort of, I think they're 5 watt fans each, nothing. So they're peanuts. Yeah, peanuts. And they're temperature controlled, so they're not running all the time. Correct. Yeah, they're because they're only 5 watts, they're really quiet as well. And we only turn them on when the cells go above a certain temperature. I was going to ask that actually. So they're very quiet. Like it's not going to be an issue if you've got one of these next to your bedroom on the outside wall of your house. No, you can hardly hear them. It's like the same as a little computer fan. Yeah, right. Okay. So nice and quiet. Yeah, and then we've sort of talked a little bit about the. Before we go into the installer dashboard, just in terms of end of life, do you have any plans for what does a customer do with this product? Yeah, so CATL, the cell manufacturer, do offer a recycle facility. So we haven't quite got to that stage yet because we've only installed 12 units at the moment for 6 months. So we've got a few years ahead of us. But that's the plan there. And I think over that time scale, there's going to be a lot of recycling plants coming up.
Okay, cool. So visualization, tell me about that.
So this is the user interface. So as we sort of talked about earlier, you can look at so many different consumers have wildly different profiles. So this guy, this house uses a reasonable amount of grid. So this is the house usage within the home. He's used on this day almost his full batteries, used 14 kilowatt hours of battery, so that's gone through a full cycle that day. And inside the house, the solar's only been used sort of 4 kilowatts, so the battery's actually been utilised a lot that day, which is good to see. So yeah, it's a pretty miserable day. So we're only getting 1.2 kilowatts on an 8 kilowatt system today.
You need some systems in Melbourne.
Yeah, I know. soon to come. And then we've got this guy who's purely self-sufficient. So there's a big range there.
Now, recently I had a group from the Melbourne University here doing some cybersecurity work, and they were basically analysing different inverters, etc., at the lab in terms of how they communicate, whether they're sort of open protocols, whether they're encrypted, but also about how you ensure security from changing settings, etc. How do you view that with your product?
Yes, I think security is going to become a huge issue, especially with VPPs coming in. The ability to control thousands of units has significant impact on grid infrastructure, right? So, we've really taken an approach of trying to design the system to be very secure from the outset. So we're using a secure AWS-based system for our cloud infrastructure. Just
check out the link below. There'll be information about where you can get them or further information. But really, I'd just like to thank James for coming all the way from lovely rainy Sydney down to my Smart Energy Lab here in the beautiful sunny Yarra Valley. Thanks a lot, James.
Thanks, Glenn. It's been great to be here and see your amazing setup.
Cool.